Okay, we got an integration problem here. It is the integral of the fraction 1 over, and everything else is on the bottom, x times the square root of 25x squared minus 2. And we're going to relate that to a secant inverse integral, which is 1 over u times the square root of u squared minus a squared du. So we got to get it in the right form, and then we can worry about what it turns into. So the first thing I see is that I have an x on the outside, which kind of lines up with the u on the outside here. But underneath, I have 25x squared, which is not just simply u squared. So let's focus on what's under the root first, because we have less control over what we can change under there. So we're going to let 25x squared be 5x squared, quantity 5x squared. So that means our u will be 5x. And then we'll let the 2 be our a squared, which means our a will be square root of 2. Okay? So in that sense, we've got a little bit of the work going on. We know what u is, we know what a is, but we don't have it where it matches up perfectly. So when u is equal to 5x, we'll make that du equals 5 dx. And let's make a little rearrangement there. Dx is equal to 1/5 du. So let's see. If we make those changes, what will happen? We will have an integral of, okay, let's leave the 1 up top for now, but dx will turn into, let's use a different color here, the dx will turn into 1/5 du. So that'll be 1 over 5 du. So there's the 5 on the bottom coming from the 1/5, and there's the du I'm putting in. Okay. Now, what do we have here? We have a little bit of interesting mess here, because in trying to replace things, we have an x out front. So this x out front, kind of unexpected. What can we do? We can say that because u equals 5x, x equals 1/5 u. So let's do that. Okay, we'll replace x with 1/5 u. Okay, that's kind of messy, but you can see how it's going to help. And then underneath we have the square root of, maybe I should make some more room, but I think we'll be all right here. U squared minus, well, not u squared, yeah, u squared minus the square root of 2 squared, since that's our a. All right, so really messy there, but let's see here. The 5 and the 1/5 knock each other out. Okay. So that when I clean it up, I have something that looks like the integral of 1 over u times the square root of u squared minus the square root of 2 squared du. So in this case, u is u and a is square root of 2. So I can pull things together, okay, because I have it looking just like this on the left-hand side, my integral definition, where a is square root of 2. So I'm going to rewrite it in the integrated form here. So that'll be 1 over a, which is 1 over square root of 2, times the secant inverse of u, which our u way over here was 5x, over square root of 2, which is over a. So plus c. So when all this is cleaned up, I believe I have 1 over square root of 2 times the secant inverse of the absolute value of 5x over square root of 2 plus c. And the only other thing I see that you might want to do with that is if you wanted to rationalize some of those square roots of 2 in the denominator. But I would not worry about that. So there's nothing to plug in, so we're at a final answer. Thank you.